Well, good evening, everybody, and welcome to Viking Television. And it's great to be here again, this time talking to you about the subject of astronomy and space, which is a subject that's very dear to Viking's heart, with the ships, most of the ships being named after the different planets of the solar system. I hope you enjoy this presentation, which is basically entitled The Exploration of the Outer Solar System, because we want to focus on the main planets, Jupiter, Saturn, Uranus, and of course Neptune, seeing as this is Neptune, the Viking Neptune week. So without any further ado, we'll go through the slides. I hope you enjoy it, and I know there's a facility to ask questions online later on after the presentation, and I'll be happy to do that with you. Enjoy the presentation, and let's get going. So basically, when we look at the solar system, the first 6 planets in our solar system have been known since antiquity. These planets, nobody discovered them. Coming out from the sun, of course, we've got Mercury, Venus, the Earth, Mars, Jupiter, and Saturn. And whilst on this particular slide, the slides aren't to scale for size, they are for scale for size, but not for distance, of course. And that's how the solar system was known for many, many years. For thousands and thousands of years, this is how we believe the solar system was. A star, the sun, with a family of 6 planets. This was to change, however, when the telescope was discovered, and in 1781 William Herschel discovered the planet Uranus. This was followed in 1846 by the discovery of the planet Neptune, and then in 1930 the planet Pluto was discovered. But Pluto ceased to be a planet in 2003, which is a bone of some contention with many astronomers, including myself, because Pluto was a planet in 1930. When I was a boy at school, everyone knew Pluto was a planet. So that's the solar system as it was in 1930 to 2003, but there's lots of different ideas as to how the solar system and indeed how the universe worked. Some of these are quite outlandish. The first of these I'll just show you briefly is the idea from ancient Egypt, and this is a drawing, a painting made from 3,500 years BC, where you've got the goddess Nut each night defeating the forces of darkness. And what you've got is the goddess Nut is the one with her feet on the ground and her hands on the ground, and the boat carrying the sun god Ra is going up her back legs, and then it goes back down near her elbow for the morning. And this is how the ancient Egyptians saw the sun. It rises every day, it gives life, it gives everything we need on the earth, but each night it defeats the force of darkness and re-emerges victorious the next day. Bit tedious for poor Nut and the sun god Ra, but that was the system, and it was accepted for many, many years. A more outlandish one than even that is, however, the cosmic turtle. And the cosmic turtle, and it is strange how this theory has gathered momentum, not just because of Terry Pratchett's Discworld novels, which have been a relatively new thing, but the idea of a sun god or a turtle with 4 elephants on the back of the turtle holding up the earth. And you can see on this slide here quite clearly, you've got the sun and the moon, and you can see the flat earth and the mountains of the earth on it. And this idea of the cosmic turtle was seen by many, many different cultures throughout history. But of course, these are quite outlandish. They're quite humorous now when we think about them, but it took the ancient Egyptians, sorry, not the ancient Egyptians, it took the ancient Greeks to actually come up with a final model that had some real credibility. And the first of these I'll talk about is Aristotle's geocentric model. And on this you can see the Earth at the centre of the universe with the 4 fundamental elements of earth, water, air and fire, each with its own properties. And then spreading outwards from those fundamental properties, or those fundamental elements, you've got the moon, Mercury, Venus, Solis, which is the sun, then you've got Mars, Jovis and Saturn, and then outside of all that, the fixed immobile sphere of stars, which were fixed and remained so in the heavens. The idea was, or they thought, that the planets were in the middle, the Earth was at the centre, and there was a dome of stars around the Earth. And that was accepted again back in 384 to 322 when Aristotle lived. So this theory was put about 343 BC, and that theory was accepted. However, there was something fundamentally wrong with this system. We now know that the Earth goes around the sun, not the other way around, but there was this explanation did not explain the problems of what we call retrograde motion. Retrograde motion is the fact that when we look at the planets in the sky, Once a year, they suddenly go backwards. They're going forward quite happily in what we call positive motion, and then they go backwards. And this caused no end of problems for the astronomers of the time. And it took a long time for that explanation to be fully explained. Another astronomer, not long after Aristotle, comparatively speaking, was Claudius Ptolemy, and he came up with the idea that the other planets, in fact, went round a point on an orbit. And you're seeing this here with the planet Mars going round the Earth. And what's happening, Mars is orbiting a point called a deferent, and it's travelling on what we call an epicycle. And this system works, except it would do it more than once a year. So although it explains retrograde motion to an extent, it doesn't fully explain it. But people at the time didn't have the time or the ability to explain that until 1543, when along came Nicholas Copernicus. And Copernicus, working as an astronomer in Poland, he caused an absolute scientific revolution. It is known as the scientific revolution because he came up with an idea which says, hang on, there's something wrong with this theory. The Earth is not the centre of the universe. What we really have is the sun is at the centre. Now, we use the word universe at this time because that's what they believed it was. But in reality, what Copernicus is saying is the sun is the centre of the solar system. And you can see on this drawing here, which I've just zoomed in a little bit, you can see the sun there in the middle and the Earth with the moon going around it. This was a huge, massive idea. And it works like this. Here you've got the planets going around the sun. I've just shown the 4 inner planets here. And what happens is the further a planet is away from the sun, the slower it goes. If you actually watch this for time, the blue blob of the Earth goes around the sun once, or around this, it goes around once, and Mars takes 2 revolutions to go around. And that fundamental idea, that theory, which was confirmed by other astronomers, and notably Johannes Kepler, some years later, actually proved that the Copernican theory of the heliocentric universe was correct. It wasn't widespread accepted, however, for some time. It took a little while, but Galileo in 1610, he started to use a telescope. And when telescopic astronomy began, it made a huge difference because all of a sudden you could now see things in the sky, and the telescopes gave far more detail. And amongst the things that Galileo saw, incidentally, the telescope was only discovered a year earlier by a chap called Lippershey in Holland. Well, Galileo actually turned a telescope to the heavens and discovered all sorts of things. He discovered the stellar composition of the Milky Way. He also published all his recordings in the Sidereus Nuncius and in 1610. And amongst other things he discovered with his telescope, this is a sketch from his, or a drawing from his diary. You can see quite clearly there at the top, you can see a star with a circle around it and little stars next to it. And what we're basically looking at here is the planet Jupiter. And these 4 little stars, up to 4 little stars each side of it, seem to move from side to side, but they never actually stray from Jupiter. And from this deduction, and from also observing the fact that Venus, when seen in the evening and the morning sky, shows phases, he was convinced that Copernicus' view of the heliocentric universe was correct. And that huge change, we could do a lecture on the Copernican revolution in its own right, and indeed one of the lectures on board the ships we currently show talks about this in detail. But for this lecture, I just want to say that the Copernicus and Galileo and quite a few others changed the universe and the way we looked at it dramatically, which led to the sun now being placed at the centre with all the planets going around it. Now, remember I said at the very beginning, we've got 6 planets. Well, William Herschel, using a telescope working in the United Kingdom in Bath, down in the south of England, he used his telescope and he discovered an object in the sky. You're looking here at a video, it's just 3 shots, and the star there is called Delta Geminorum. It's the 4th brightest star in the constellation of Gemini, and the blob moving from the middle to the bottom is in fact the planet Uranus. And this was a huge discovery because it now meant the universe, or the solar system, has grown now from 6 planets to 7. But there was something fundamentally wrong with the motion of Uranus. It didn't move exactly as it ought to have moved. And this led to scientists believing there must be another large planet out there. And this was what led to the discovery of Neptune. And the discovery of Neptune is actually a great example of what I would call a British farce. Because the discovery of Neptune, just about 60 years later, happened like this. In 1845, the British astronomer John Couch Adams, working as a postgraduate at Cambridge, worked out mathematically where he believed this new planet would be. He worked it out because the wobble on the Uranus orbit meant that something was pulling on it, and that was where he thought there would be another object to be found as this happened. Well, he thought he'd worked out where this new planet was, and he explained his theory to Professor James Challis, his professor at Cambridge University. Challis, however, was far too busy, and despite Adams' insistence, Challis failed to follow up and check on Adams' theory, much to the consternation of poor John Couch Adams. In the meantime, a French astronomer in 1846, Jean Leverrier, calculated the position of this new planet, again mathematically. Leverrier, however, told his friend, the German astronomer Gall, of his predictions. Gall went back to his Berlin observatory, and with his assistant D'Arrest, they used a new set of star charts, looked for and found the brand new planet, which is shown here with the Earth to size. This led to a major diplomatic incident involving the Germans, the French and the British, and it actually, if you think Brexit was a problem for the UK, this was even worse because it really did cause a huge diplomatic incident, and it eventually was settled when they attributed the discovery of the 8th planet in our solar system to all 4 men. But even now, if you look it up on Google and things like that, you'll see that most websites will say that Neptune was discovered by Gall and his assistant D'Arrest. And poor John Couch Adams didn't get a look in really until much, much later on. And that's our first reference to the planet Neptune, which is of course the subject of our talks this week. If we move on, the planet Pluto, because the wobble of Uranus and the wobble on Neptune still were not fully explained. So efforts were made to try and find the next planet. They believed there was another planet out there, and Clyde Tombaugh, looking at this wobble, worked out where a new planet would be, and eventually, using the telescope in Flagstaff, Arizona, Tombaugh discovered the planet Pluto. And if we look at the arrow there on the screen, you'll see there's an arrow pointing to a dot. If I press my button again, you'll see it moves ever so slightly to the left. That is a machine called a blink comparator, and using this you can see the motion comparing the star fields, which will remain the same. Anything that moves will show in that picture. This was a great discovery, and this led to the 9th planet in our solar system, Pluto. Problem was Pluto was not big enough, and that was to cause Pluto's downfall in 2003, which we'll come on to in just a minute. So far, we've been looking at the discoveries of the solar system, the major discoveries of the planets, and all of the efforts, all the means by which we can do that are done with naked eye observations. Yes, naked eye observations, and also by using telescopes. But you're stuck on the planet Earth. You can't do anything other than look with the eyes and the various instruments you can use. But of course, just over 75 years ago now, the space age began on October the 4th, 1957.
On October 7th, 1957, the US and the rest of the world were greeted by the sounds of Sputnik 1. The Soviet Union had placed the first artificial satellite into orbit.
So having made this discovery that we could use spacecraft to go into space, that meant the solar system was now open for exploring with these various spacecraft. It didn't take very long at all before the Russians sent a spacecraft to the moon. Only 2 years later, the first spacecraft went to the moon. And that was just the start of interplanetary exploration. The subject of the discovery of the moon and spacecraft to the moon is, of course, a subject we could do at length at another time. But basically, if you want to explore the solar system with spacecraft, how do you do it? Well, it's very simple, really. What you do to start with, you send a spacecraft out and it flies past. It's a flyby mission. You then send a spacecraft with more rocket power or more engines or whatever to get it into orbit around that planet. The next step will be to send a spacecraft to land on that planet. You'll then send a vehicle that could rove on the surface of the planet. You'll then take samples of that planet, and then eventually human beings will go to that object. That's the basic means and the development of how we explore the solar system with spacecraft. And this next picture now shows you what we have managed to achieve so far in just 75 years. It really is quite incredible. In green, you'll see the achievements. In yellow, we see that missions are proposed, and in red, there are currently no plans. Well, you can see at the top there, the moon, of course, started off in 1958 with the first Lunar 1, went right through to 1969 when they landed the Apollo 11 spacecraft on the moon. And you can see the flags of the nations involved on that slide. Next line down, you've got Mars, and you can see we've got sample return missions and human missions scheduled for Mars in the not too distant future. We could actually argue that on Mars, they have actually taken Mars samples now, because the Perseverance rover on Mars is actually depositing samples on the surface of Mars for collection in about 2030, and so on. So I won't go through the whole slide, but you can see there how we've developed. And this slide I update from regular occasions, and indeed the yellow boxes of Uranus and Neptune are a recent addition, because it's only been announced recently there are now plans for orbital missions to both of these outer planets. So that's how we discover the planets, with spacecraft. One of the most important missions that we did undertake to get to the solar system was the Pioneer spacecraft, and the Pioneer 10 and the Pioneer 11 spacecraft, launched in 1972 and 1973 respectively, were the first attempt to get to our outer solar system. They were an amazing success due to a phenomenon known as gravity-assisted trajectories. Pioneer 10 and 11 were sent to the planet Jupiter, but it was realized literally after Pioneer 11 had left that if Pioneer 10 was successful at Jupiter, they could use the gravity of Jupiter to send Pioneer 11 across the solar system to intercept the planet Saturn. That was done, and that gave rise to a whole new different system of how we can get to the outer planets. In the meantime, however, unfortunately, Pluto lost its title. In 2003, we discovered another object in the outer solar system. This object, named Eris, was thought to be bigger than the planet Pluto, and this led to the idea that Eris was in fact the 10th planet, again discovered because of gravitational perturbations on the orbits of Uranus and Neptune, and indeed on Pluto. Well, Eris was thought to be bigger, therefore it was the 10th planet, but the International Astronomical Union did not agree, and they decided that Pluto, being quite small, along with Eris and other similar objects, should be redesignated as dwarf planets. And that's why children today only have 8 planets in the sky to look at, whereas when I was a child we had 9. And I'll make a prediction now that we are actively looking for another planet in the sky, because we still believe gravitationally there's something else out there, and there's lots of work going on as we speak looking for this 9th planet, or would have been the 10th possibly. Well, when we finally discover it, I'll bet it gets named with a letter P in front of it, so all the mnemonics that people have had all those years about naming the planets and having the order of the planets known to them will work again. But that's Pluto, and we're not talking about Pluto because we're talking about the planets now, not the dwarf planets of the solar system. Because in 1965, a chap called Gary Flandreau of the Jet Propulsion Laboratory in California, he realized there was a very distinct and rare opportunity to send one single spacecraft to the outer solar system, which would in turn visit Jupiter, Saturn, Uranus, Neptune and Pluto, all lined up on the same side of the sun between 1976 and 1978. Using the gravitationally assisted trajectories I mentioned earlier, it would be possible to send one spacecraft to all of those planets. This rare conjunction, or this rare alignment of the planets, only happens once every 175 years. So timing was quite critical, only about 10 years to go to design the spacecraft and get it out there. But it would be an amazing opportunity, and one that was grasped fully by the United States and NASA, and they started developing the possibility of sending up to 4 possible spacecraft out to that region of the outer solar system. Well, 1973, unfortunately, this was just after the moon landings had finished. The public desire for spaceflight had lessened considerably, so citing budgetary constraints, the 4 spacecraft that were scheduled to do the Grand Tour was basically completely cancelled. They did, however, agree to sending just 2 spacecraft using the original Mariner type spacecraft that went successfully to Mars and to Venus successfully earlier. They decided to use these type of spacecraft just to go to Jupiter and Saturn, and they would the 2 spacecraft would just visit Jupiter, Saturn, and these were designed and renamed Voyager 1 and Voyager 2. And although this was a disappointment at the time, it was still a lot better than we'd had previously, because we'd seen Jupiter and Saturn with the Pioneer spacecraft and we wanted to know more. And the Voyager 1 mission was scheduled to work like this. The spacecraft would leave the Earth, would then travel across the asteroid belt, intercept the planet Jupiter in 1979, get a gravitational assist from Jupiter, which would sling it across the solar system, where it would intercept Saturn in 1980. And Voyager 1 and Voyager 2 were to follow similar trajectories. One thing they did realise, however, I'll just let that run for a moment while I just tell you the next bit, because one thing they did realise, that this would be mankind's first attempt to send a spacecraft out beyond our solar system. So it was decided to make a long plane record, and on this long plane record they would have the features of the Earth. The aliens would find this sometime in the very distant future, and they would realise that this record was a record with a stylus. I mean, nowadays, I remember LPs and 45s vividly, but I know people do still collect vinyl. But the idea of this sort of equipment being needed or being used on a spacecraft is quite laughable, really. But at the time, this was the technology they wanted to use, and this gold record was installed on the side of the spacecraft. On the record, as well as the actual sounds on the record, we also had the waveforms represented, the signal on the disk. We had the image presentation, we had the circle calibration, we had the hyperfine transition of neutral hydrogen, and we also had a map showing the indications of where the sun was in relation to the other planets of our solar system. The record was placed on both the Voyagers and was launched into space, and just a quick snapshot of the messages on it are included in this next little video.
As the Secretary General of the United Nations, an organization of 147 member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet.
So it's incredible to think that the music on that long playing record, from the works of Mozart and Beethoven to Chuck Berry, may possibly be played on a record player somewhere out in the outer reaches of space sometime in millions and millions possibly of years in the future. But after all the work was done, after the spacecraft had been designed and checked and everything else and installed on the rockets, the two spacecraft were scheduled to be launched just a month apart. Incidentally, for a quirk of fate, Voyager 2 went first and Voyager 1 followed about a month later.
2, 1, we have ignition and we have liftoff. We have liftoff of the Titan Centaur, carrying the first of two Voyager spacecraft to extend man's senses farther into the solar system than ever before.
What was to be fascinating about the whole concept of the Voyager mission was, after the launch, just a year later, the idea of sending Voyager 2 to Uranus and Neptune, as well as Jupiter and Saturn, was revived. And the NASA scientists at the time had always known this was a possibility and hoped it would happen. But it would only happen if Voyager 1 had a successful transit to Jupiter and then to Saturn. A plea was made that the Voyager 2 spacecraft, which although it launched first, got to Jupiter and Saturn later because of slightly different trajectories, a plea was made that could we please send Voyager 2 on to Uranus and Neptune? Because the NASA scientists, I suppose, had disobeyed their instructions, because although it was uncertain before the launch, the spacecraft had been hardened and made capable of reaching Uranus and Neptune and lasting longer. This was eventually accepted. And so now, instead of both spacecraft just going to Jupiter and Saturn, they were going to send Voyager 2 if Voyager 1 was successful, on to Uranus and on to Neptune. And this is now the revised profile for the Voyager 2 mission. Again, the spacecraft leaves Earth, goes past Jupiter, then goes past Saturn, then is slung on and reaches Uranus in January 1986, and then finally in 1989 it goes past Neptune. That was the plan, and of course it worked brilliantly. Both spacecraft performed successfully at Jupiter and Saturn, and then went on Voyager 2 to Uranus and to Neptune. At the planet Jupiter, the Voyager 1 spacecraft managed to image it from January right through till April. This is a montage showing the main planet Jupiter and its 4 Galilean moons, so named after Galileo, who discovered them back in 1610. It got as close as 217,000 miles above the surface of Jupiter, and this was followed from April right through till August. So we got a full 8 months of observations of Jupiter in 1979, and a little bit further out, Voyager 2 was 350,000 miles above the surface. Some of the things they discovered were amazing. The volcanoes erupting on the innermost moon of Jupiter, Io, since been photographed by other spacecraft, and it's an amazing idea that we've got volcanic eruptions taking place not just on our Earth, but also on other objects in our solar system. We also discovered that Voyager discovered Voyager 2, this image, showed that there are rings around Jupiter, just like there are rings around Saturn. They're only visible to spacecraft. They're not as dramatic or as sensational as ones around Saturn, but nonetheless, they are quite vivid and easily spotted from the Voyager mission. The Voyager mission, just to break away from Voyager just for a moment, the Voyager mission led to such interest in Jupiter that this was followed by the Galileo mission. And the Galileo mission, launched from the Space Shuttle Atlantis in 1989, also went to Jupiter and discovered that the volcanoes of Moon repeatedly changed the surface. Europa, one of the other moons, has got a subsurface ocean with more water on that moon than there is on the whole of our planet Earth. And the whole discoveries and the whole idea of looking at Jupiter in detail grew and grew and grew. So much so that the Juno mission was launched in 2016. So it was launched in 2011, got there in 2016. And like Galileo, when the mission is over, they will intentionally send a spacecraft into the atmosphere of Jupiter to burn up so it won't pollute the moons of Jupiter, which are the most fascinating objects in our solar system. There are 2 more missions scheduled to go to Jupiter in the very near future. One is launching later this year in May, the European Space Agency mission JUICE, wonderful name for a spacecraft. JUICE stands for Jupiter's Icy Moons Explorer. That will launch in May and arrive in Jupiter in 2030. And we've also got NASA's Europa Clipper going to the moon Europa. That will be launched in October 24. But back to Voyager. The Voyager 2 and the Voyager 1 spacecraft both, of course, intercepted the planet Saturn. Voyager 1 got there in November 1980 with a close approach of just 77,000 miles. This was the end of the Voyager 2 mission, and it only went as far as Jupiter and Saturn. Originally, the plan was to go back to the original idea of the Grand Tour. The Voyager 1 would have then gone on to Pluto, but that never happened. That was never able to take place. It subsequently happened with the New Horizons probe, which doesn't feature in this lecture, but we did get out to Pluto with New Horizons only a few years ago. Voyager 2, in the meantime, went even closer to Saturn at an altitude of 63,000 miles in August 1981. And no picture of Saturn would be complete without, or an image of Saturn without these wonderful rings, which really are spectacular. And we often say in astronomy, show a child Saturn through a telescope and they'll be hooked on astronomy for life. Certainly happened to me, and I hope I get the opportunity to do that on board one of the Viking ships in the near future. We have actually got telescopes on the Viking Orion and the Viking Jupiter, so that's something maybe you can look forward to on one of your trips with Viking in the near future. Other spacecraft to Saturn, there's only been one other spacecraft to Saturn, and that's the Cassini mission, which went into orbit around Saturn between 2004 and 2017 and sent back amazing, spectacular pictures, including a wonderful one of the Earth from Saturn, which really is, again, an iconic picture. But just like Galileo before it and Juno, which will follow, the Cassini spacecraft deliberately was sent into the Saturn atmosphere in 2017 when it ran out of fuel, just before it ran out of fuel, so it would not pollute the moons round Saturn, which we do believe possibly could contain signs of not ancient life, but primitive forms of life may exist on the moon Enceladus and around Saturn, and possibly on Europa around Jupiter. The Cassini probe also achieved the first ever deployment of an atmospheric lander. This is a spacecraft deployed from Cassini called Huygens, and the Huygens, dangling on its parachute here, is descending to the surface of Titan, and what you're looking at here are methane lakes of pure methane. The spacecraft landed on the surface. The thick atmosphere of Titan meant that the spacecraft didn't last for very long, but this is an actual picture taken from the surface of the moon Titan round Saturn by the Huygens probe. We'd love to go back to Saturn. We're going to go back to Saturn hopefully in the late 2030s, but it's depressing when you read these things and you realize that this mission won't get to Saturn until the 2050s. And I'd like to think I'd still be here, but I think it's probably unlikely. But this spacecraft, due for launch probably the late 2030s, is on the drawing board and is a real possibility to be sent to Saturn, as I say, in about 15 years' time. In the meantime, the Voyager 2 spacecraft achieved its goal of getting to Uranus, and it approached Uranus and got there on the 24th of January at an altitude of just 50,000 miles. Discovered 11 new moons, the rings of Uranus. We always knew there were rings of Uranus because observations from telescopes on Earth had shown that when Uranus goes across a background star, the light changes, so it indicated that we thought there was a ring system around Uranus. What we didn't expect was the amazing, in the foreground of this picture here, you've got the moon Miranda, which looks as if it's been completely shattered and then reaggregated. And that was a completely unexpected discovery. The actual planet of Uranus actually rolls around the solar system. Its axial tilt is about 98 degrees. So unlike the Earth at 23.5 degrees, Uranus has got a major tilt, so it rolls around the solar system. And that is evidence in this picture here, showing the false colour views, showing the thickness of the atmosphere and things like that. Uranus wasn't particularly fascinating to us as astronomers, but it did show quite clearly, I'm just go back a second, it did show quite clearly that the moon Miranda showed some signs of some devastating event taking place in the way distant past. So we want to go back to Uranus, and this one is now actually being approved for development. In 2022, it was agreed by the Planetary Science Decadal Survey for the years 2023 to 32 that they would send a probe to Uranus. The reason they want to go to Uranus ahead of Enceladus or indeed Neptune is because of this problem we've got with the moon Miranda. Something caused Miranda to be shattered into thousands of pieces and then gravitationally reassembled itself. But the Voyager probe took wonderful pictures. These are the backlit rings taken from about 146,000 miles away, and this is Miranda, a really chaotic surface you can see there. It looks almost as if someone's got it together and pushed it together like a snowball, and that really is something that we're excited to know about and try and find out why it happened. We are curious on the Earth. As human beings, we're very curious. We always want to know how, why, when, where and what, and this is one of the big questions we've got out in the outer solar system. The final spacecraft, or the only spacecraft to have ever visited Uranus and indeed Neptune and Uranus, was of course Voyager 2, and Voyager 2 finally got to Neptune in August 1989. And at an altitude of just 3,000 miles, they weren't as cautious as they were with the earlier encounters with Jupiter and Saturn because they wanted to preserve the spacecraft for its final encounter. They actually sent Voyager 2 very close to the planet Neptune at just 3,000 miles, and it discovered that Neptune as well had a dramatic ring system, and it discovered 6 new moons. And like Jupiter's got a big red spot, Neptune has got a big dark spot, the Great Dark Spot, and this has since been discovered, has disappeared following observations by the Hubble Space Telescope. And what we think we're looking at here is literally a window looking into the inner atmosphere, and this hole in the clouds at the top enabled us to do so just at that one moment as the Voyager 2 spacecraft went flying past. It did give us concrete signs and evidence that the ring system was quite dramatic, and ironically, I'll come back to that picture in just a moment, but the flybys of the moon Triton Triton is one of these other enigmas in the outer solar system, and in fact it was touch and go whether they went to Neptune or they went to Uranus with the next mission, which was scheduled for the late 2030s, because Triton goes round Neptune backwards. It's in a retrograde orbit. This would indicate that that moon's life cycle, its time around Neptune, is probably limited, and it may well eventually shatter into thousands of pieces and form another ring around Neptune, or possibly impact on the surface. We aren't 100% sure. We need to know more, and that's one of the things that we want to do with another mission. But all these missions are, of course, subject to budgetary constraints, and I'd love to see that their mission went off to Neptune a bit earlier than that, but I think it's somewhat unlikely. And the final photograph from Voyager 2 shows Triton in the foreground and the planet Neptune from just 3 million miles, and it shows this dramatic picture taken on Valentine's Day 1990, which is of course only next week, and it gave this wonderful picture as the final spacecraft of the Voyager planetary encounters took place. We have got a proposed Neptune mission. This one will go into a retrograde orbit around Neptune and look at the moon Triton, and it is possibly going to get launched as early as 2031, and we're arriving in Neptune in something like 2049. But how appropriate that we're talking in Viking Neptune week about the planet Neptune, which is the newest ship in the Viking fleet at the moment, because the James Webb Telescope, which was launched so spectacularly and so successfully back in 2021 on Christmas Day, when it released its first images that it took with the cameras on board the JWST, one of the first pictures it released was this. This is the bright star in the middle of the picture. There is the moon Triton, and at the bottom there you see the planet Neptune with its ring system and the moons. And it really is quite spectacular that that picture was able to be taken from a telescope in orbit around the Earth, but the resolution of this instrument is absolutely dramatic. And again, one of the lectures we present on board the ship when I'm on the Viking ships doing lecturing and cruising is about the James Webb Telescope and the Hubble Space Telescope. But I want to leave you with an idea that came about at the end of the Voyager missions. The Voyager missions were outstandingly successful. They probably did more to promote astronomy, just like the Hubble Space Telescope and indeed now the James Webb have done over the last 30-40 years. But it was requested that Voyager 1, when it left Saturn after its final encounter, the spacecraft was still working and it still had the ability to take pictures. So what they did, they took a picture, and this is the actual composition picture showing not all of, but most of the planets in our solar system from its vantage point out beyond the planet of Saturn. And looking back, as I said, on February the 14th, 1990, about 4 billion miles away, we've got Venus, we've got Earth, we've got Jupiter, we've got Saturn, we've got Uranus, and we've got Neptune. Unfortunately, Mars and Mercury were too close to the sun and we couldn't get an image of them. We are now looking at that Earth image here. This image Earth, the dot, the tiny little dot, that is the planet Earth from Saturn, looking back at Saturn from this spacecraft built and manufactured and launched all those years ago. To commemorate this actual image being taken in 2020, NASA reprocessed this image, and this image showing what was to be known as the pale blue dot has become one of the most evocative and amazing pictures from space ever taken. And I want to leave the final words in my lecture to none other than Carl Sagan. But before I do that, thank you very much for listening. I hope you've enjoyed having a look at the outer solar system, and appropriate enough with the planet Neptune in particular. And I do hope we can see you on board sometime in the near future on one of the wonderful Viking ships, not just the Neptune, but there's a whole host of them now. We cruise the world, see the world in comfort with Viking, but remember, as ever, we can always look at the pale blue dot from space and hear the words of Carl Sagan describing what we're looking at.
From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on the mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot.